Hi, hi everyone. This is Dr. Vishweshwar from EC Department, SNS College of Technology. Here I am with my mentees for discussing a topic named building a responsive audio clipping system using operation amplifiers and diodes using design thinking approach. So here in this world, we are using many audio systems, speakers, and headphones, etc. So which are mainly spoiled with by the high distortion signal, high distorted input signal. So this is a major problem in the audio system. So which was going to discuss by my students using design thinking approach stage by stage. So my student Vikas will start the session.
Hello everyone, I'm Vikas. I'm going to speak about the empathy part of the audio systems using DT approach. We started to analyze the real-time problems. In real-time problems, we use the audio systems. In audio systems, we interviewed the music producers, audio system workers, and some of the engineers who are studying the audio amplifier circuits. According to them, most of the problems in the systems are occupied by the distortion of the signal, and the peak point reaches immediately. So it may cause the damage to the amplifier circuit and amplifier circuit and the speakers which we have using. So we want to use because we are using cost-effective things, cost-effective speakers and audio amplifier circuits, which is slightly in low price. The using of the high price components may be used to damage this. So we want to design a cost-effective amplifier circuit, and it should be work without the distortion of the peaks. It may cause the high noises like clapping sounds and the high peak which leads to the maximum voltage. So the maximum voltage may cause damage to the entire system, and it cannot be replaced with the other stuff. So the total system will be damaged. So our empathy part is, the question is to design a cost-effective audio amplifier circuit and speaker in a cheap price.
Hello everyone, myself Vishnu. I'm going to take with define an ideation phase. So we looked at various analog signal conditioning methods. We found that using diode, it is the simplest way to regulate the voltages. But the diodes are responding very slowly, and the higher level signal is needed to start the process of clipping. So we just introduced op-amp, which acts as a gain amplifier, and it makes the clipper circuit more precise and sensitive. And we also gone through using Zener diode. The Zener diode gave us an exact set of threshold voltage, and the above or below the voltage will be clamped out. Now here the innovative part, like the signal will be amplified by the op-amp before it reaches the diode, and the diodes will remove the excess signal which is over the threshold value, ensuring no peak passes, and at the output it will retain the shape of the signal in the clipping curve. So that we can propose a perfect system for audio production, like using LM741 op-amp with Zener diode and silicon diodes.
Hi everyone, myself Vijay Krishna. We have moved on prototyping and testing phase. Our circuit is simple but it was smart. It consists of LM741 op-amp and buffer configuration, and two 5.1 volt silicon diodes, and two normal diodes which are used in this circuits. We have tested and designed the project in LT Spice configuration, which is a specialized tool to design it. And at a low temperature, at a low amplitude, less than 5 volts, the output is followed by the input perfectly and successfully. When it exceeds above 5 volt, the amplitude was hit by the Zener and clipped to the circuit. the transition was smooth, and we have connected microphone, the microphone diode as input, and we have checked the waveform with actual voice. The waveform shows clear response, and until it was risen by a high voice, and when we are clapped at the high frequency, and it confirms that our design works on the real-time application.
Hi, I'm Vikas, and today we're going to say about the application, real life application, learning, and the reflection. And in real life, we are going to see about the reflection using this op amp. We are using so many circuits and devices in our daily basis, and there are 4 devices I'm going to say. And the first one is the guitar amplitude, where the string strikes out the sudden beat and shifts the output. And second one is the smartphones and devices, where to prevent the audio control. And the third one is the hearing aids. It controls the audio level for better use of the user. And the last one is the control of the smart voice controls for better audio and the clear clarity of the voice and the pictures. The major points are 3 points. First point is the low cost, where it is very cheap and it is affordable to everyone. And the second one is analog component, where analog is used for the ADCs to control the microcontroller of the chip. And the last one is versatile and flexible to everyone. Everyone is handy to use and it is comfortable for everyone. It is where it is implemented by the design thinking. And we have used the op amp. By learning the op amp, we have created a project or some sorts of projects where the op amp circuit is inserted, and it is used in various components for our daily basis also, and it was very useful, and it is very implemented for the life.
Okay, after seeing my mentees discussion based on the chain thinking approach, we are excited that just by using the operational amplifier and diodes, we have built a very good audio filtering circuit for a better performing audio system. So with this, we can end this video. You can join in the next video. Thank you.